Okay, a quick introduction about DevOps. It's not a goal, it's a never-ending process of continuous improvement. So that's, we say, that's just humble say, it's a great guru of DevOps. So most of time, people have a technical approach of DevOps. I will try to introduce you a more human approach. So let's focus on the mindset. Developer mindset are pretty different than ops mindsets. They have a culture of innovation and applicating value. Most of the time, they are under pressure from the market. I mean the market, I mean enable new application, modernizing, and most of the time they think ops are break to innovation. That is most of the time true, because ops have a different mindset. They have the culture of zero downtime. They need stability, normalization, and fixed rule to ensure SLA. And as I say, a change is a managed risk. Because I'm an ops, I born in ITIL, but now I'm converted to agile methods. Okay, let's talk about we talk about the dev, the ops, and not the Z factor. Everybody is pretty convinced that it's the most powerful platform in the market, super most of trending technologies, can also be virtualized, and is cloud ready. And if you make a small calcul, Z plus dev plus ops equals Z DevOps. This means dev plus ops means merging two cultures together, two different mindsets together. Z plus dev plus ops is about merging these two cultures with a strong and innovative solution. But the most important challenge, on my experience, is to break the silo between dev and ops, because they don't have the same mindset. It's to join them to a common goal, a common mindset to face up the DevOps initiative. We also focus on a technical approach, that everything that is done twice must be automated. That's the main discussion we have about continuous integration, continuous deployment. So to do that, we have to normalize developer experience. So we have a lot of solutions, a lot of mantra. Use one solution to address multi-platform to reduce tool chain complexity, like Topaz or RDZ or WASI solution from IBM. The goal is to make the mainframe technology like any other for the developer. Of course, you have to support multiple languages, and best of all, no more green screen, if possible. And last technical approach is to measure KPI, because you cannot be sure that you have a good improvement of DevOps if you can measure anything. You also have to get the best from all mature technologies. The best example to illustrate the last presentation is to use ZOS Connect or RESTful API for DB2, for CICS, for ZOS. You have plenty of solutions available via ZOS Connect. And to speed time to market, you have to reduce the learning curve for the new developers that are coming to the teams. So it means you have to have a simple tooling chain to help them to be focused on the métier, on the sorry, excuse my French. And last point to speed up time to market is to automate. Automate because everything that is done twice should be automated. The last point is the organizational approach. In my experience, I have managed a DevOps transformation, and I was in opposition with ITIL because I'm agile now, you know, and ITIL process are here to guarantee SLA, security, and zero downtime. Anyway, agile can be a little tough for ops sometimes. So the best approach is to co-build the software factory with end user and ops also. This means you have to share ideas. You have to end the product to be to get the best solution, your own solution built by the community. You have to set up a cross-functional team. Why? Because if you manage all the competence inside the same team, it's more easier to have a quick result. And create a community. My experience is to involve developers in the product, in the software factory implementation, because they have ideas. They know how to work, and we need to apply what they want. Because if we don't do that, they will not use the solution. I have already had an experience which we set up a game of bug hunting with prize. For example, a drone or a new laptop. And we start with 20 people playing. At the end of the week, 1 week later, there are 200. Just because we manage social networks and serious gaming. And last, don't forget to simplify the EITIL approach, because it's a break for innovation, it's a break for DevOps, but you have to manage with ITIL because it's good for the SLA, for the operation. Okay. And for conclusion, I have a few key points. It's about construction, find accommodation on ITIL, get a cross-functional team, most important thing, and feel free to experiment. As mainframe engineer, I also try Python language, COBOL language. I never do that before, but I try it because I know the people who are developing are using this language. I have to know how they work, and I experiment some Python scripts. Nothing terrific. Create an active community, listen and apply end user feedbacks and suggestions, and deliver small but often. Because if you wait too long for delivering, you will lose your community. So deliver often, sometimes with bugs, sometimes without, but often. And the last point, get KPI to monitor and reporting to manage the process and the evolution of your DevOps. And now, Benoit will explain you how NRB has managed its DevOps transition. Thank you.
It came back to the start. Okay, that's good. Thank you, Jérôme. So after this, I go a small dive into what we do for the DevOps on the mainframe at NRB. And for this, I am talking about 4 points. The first thing is modernize the user desktop, why we needed that for the developers. We finished installation and configuration of ISPW as a start for DevOps for our clients. I explained why we use ISPW, what we do with that. I explained soft metrics of the advisor. That's an Elasticsearch capabilities with a lot of information in it, and you can keep an eye on what your developers do into your source code management with the build and so on, and what we can do with that. And finally, what we do in the future to integrate the mainframe into the release management of the complete company. So why we need to modernize your desktop for developers. Classically, the developers use TSO, ISPF to manage the source code, developing COBOL, PL1, JCL, so on. But now with the modern tooling like the Git, the Java, and the source code management, the deploy, the build outside the mainframe, you need to also outside the developer's tool from the mainframe. In this case, we take the Topaz Workbench. It's like an RDZ stuff based on Eclipse. You have also the capabilities into Visual Studio Code or into the WASI stuff. And the goal for that is to have more capabilities into your new tools that you can have into your TSO. Your developers doesn't want to kit the TSO if you don't offer something more better than what they have now. Here, there's some example of what you can do with that. For example, you can have the includes linked into your source code. With that, your manager, your developers can work and directly see what's inside the include they use and directly connect the information, and they didn't need to switch from one screen to another to end information. Everything is linked together. You can have also the coding help for all the information you want. If you start to code the if, you have all the stuff that you directly include into your code. They also include all the information from the include, from your structure, from your variables, and you maybe have a quicker development with that. You also have the overview of the code. All the code is parsed, and you have the overview of your variable, your procs, your include, and so on. And you can move quicker into your code and go to directly to the straight to the point and change what you need to change. You also have a syntax check that can be very good, because before you compile something, you be sure that almost the syntax is correct, and maybe your compile file for something else, but your syntax is good and you don't waste the MSU for a compilation that's do nothing for that. And finally, something I think is very useful is the graphical compare merge. You can compare the mainframe through, but the merge is very difficult. In this case, you have some tools that you can graphically see the difference and do the merge automatically or manually, but very quicker rather than you can do into TSO. After that, the installation configuration of ISPW we do for one of our clients. What is the environments of these clients? It's a PL1 clients, full PL1, no COBOL, no assembler, just PL1. MFS because IMS, PSB, batch, PSB, IMS, DB2 copybook, and DL1 copybook. That is the environment we have. That's more or less classic, no complications. But if we do a deep dive into this, you can see that you have 85 type of compilations. If you take all the stuff and you see all the different options we can have 85 type of compilations. That's a lot. You can do up to 12 load generated from one sources. 12 load with different names, some case. Fortunately, most of the time it's 1 or 2 load generated, but that's very complex and you need to manage that. On some LPAR, part of the loads, it's on the LLA, so you need to go and do an LLA refresh on some LPAR with some rules on it and something like that. For some objects, you have the memory tables, and you need to update the memory tables when you do the deploy into the LPAR. So it's another stuff that it's not classic on a mainframe, and you need to manage it. And of course, like a lot of other customers, they compile everywhere, every time. So we want to stop that and squeeze these compilations and just compile what we want to compile. Before SPW, we try several other tools, Sirena and RTC, and it fails. That's why we are on ISPW and not on other tools. And why it fails? is because, firstly, the development was not involved into the choice of the tools. When the tools is choose, we go to the dev and see, yes, this is the tools we want to use for you, and they say, oh, that's not working because this on that, you don't see this, you don't see that, and so on. Also, as you can see, this is not an easy client, and the tools, the RTC and Sirena at this time was very rigid. So it's very complex to quick out the tools to be fit for us. That's very difficult. And the last thing, I think, it's we try with this to do everything in one. Do the SCM, do the build, but also integrate the mainframe into the release management of the company. And we want to do everything in one step. And I think that's not very good because it's too much. So what we do when we try another source code management and we try ISPW, for the choose of the products, we directly have an involvement of the developers. Some developers was there, we check all the different candidates with them, and we already have a big screening of what is the good point, what is the bad point of everyone. When we do the POC, also, we do the POC as a system team, but the developers do the POC also as the development team and check if it's fulfill what they want to do with the tools. When we implement the tools, also the development was every time there, and every choice we want to do for the tools, we do it with the developments involved in it. So we never say, okay, we compile this like that, it's okay. We always do that with the development because they use the tools after that. We also do the choice that the first line of support and training will do by the developer itself also. I think developers talk to the developers is more or less better that the system team go down with a ivory tower and explain what they want to do. And lastly, we do the step-by-step implementations, and we don't want to do in one step, one by one, and we go to the end. So what is done right now? ISPW is fully functional as a source code management. It take all the deploy and the build from the dev to the production parts, and we try to not compile when we don't want to compile. For example, in productions, we didn't recompile anymore. That's the goal. What we do now, it's to integrate it into ISPW, into the development, into the release management of the entire company to be sure that everything is linked, and when you deploy something, everything is deployed at the same time, at the right moment. We also want to deploy the jar file and ZOS Connect file through the same interface that the peer one sources. So when we deploy something, everything is deployed by the same tools, and be sure that everything is deployed correctly. We also try to integrate SonarLint, SonarCube integrations. We are on peer one. That's not the same as the COBOL, so we need to try. And also the test management tools is very necessary to be sure that when we do some tests, regression tests and so on, we want to be sure that we have the correct data and we can replicate the test. So a quick overview of what we have for the advisor and the metrics you can have. What is the advisor? It's a free computer BMC now tools you have when you have some license from this vendor. It's built on Elastic. It's an ELK stack on the cloud, and they collect a lot of information from your systems like ISPW stuff, and is very interesting in the DevOps world because you have some panels that can be very good, and I do a focus on 3 panels. The first one is the development productivity. What is that? Is how many times a change need to be done? How many times it need to be tested? How many times from the checkout to the promo to productions you need to do something? It has 3 different parts. I just show you one, but it's the same for every time. So the lifecycle complete is from the checkout to the productions. The testing phase is how many times you need after you change something and you do the promo to the production test system, to the test system, and you need to test the change before put in productions. And the last is the development parts, is how many times you need to create something you need, change the source code and push into the development system. I think there it's real information from our real clients on 90 days. And you see, for a complete life cycle, it takes more or less an average of 2 weeks to do the change. Maybe it's good, maybe it's bad, I don't know. That's not my business, but they need 2 weeks for change something. In a DevOps environment, maybe 2 weeks is good, maybe it's too less, I don't know. This is good, but you have more details on it, like this. And you can see on the right that the longest time in life cycle, some components need more than 100 days to be complete. And this is very interesting because you can see that you need maybe more than 3 months to change something. And that, in the DevOps environment, that's very complex to manage that. So this information can be very good for developments to check what happened and how you can correct this. The second thing good is the refactoring candidate. It can help you to detect the source and the program that you change the most and the source and the program you regress the most. Why it's important to have that? Because if you change a program very often, maybe you need to split it, maybe it's too big, maybe it's too complex, but it's something to have a look. And you can see there on the 90 days, you can see that some program is checked out more than 100 times on 90 days. That's a lot. So more than one a day, it check out the programs. That's not correct. You need to check that, and you need to see why you do that and have an action into that. You can have more detailed information on the most checkout, the most regress program, etc., etc., etc. But that's very good to have this information, because without this kind of information, you can't see where the problem is, and you didn't detect the problem you can maybe have on the sources in the future. And the last part is more on the source code management KPI itself, and you have more trend weekly for the number of packages you have deployed on average weekly, the number of components, etc., etc. And if you are good enough to the deploy, maybe you deploy not enough into the DevOps system, and so on and so on. And you can go deeply also on the application, which application is the most deployed, which type of sources is the most deployed, and also the usage count. It's which user used the most your applications. That's good, but which user didn't use correctly your applications. That's kind of good also to check with him why he didn't use it correctly. And finally, what we want to do now, because it's okay, we have your source code management, deploy, release management on the mainframe, but it's not integrated into the whole enterprise. What we want to do is to synchronize the mainframe and treat the mainframe like any other type of load management. Okay, you have the Windows, you have Linux, you have the mainframe part, but we want at your release management manage everything at the same. So what we have a source code management. It's this slide. I put GitHub in some time and ISPW in the other hand. You can have also just the full GitHub is the same, but you have different type of deployments. You can have the Linux, you can have the mainframe, you can have Windows. But at the end, you want that you would automatize the deploy from the GitHub, from your mainframe, SCM stuff. And for that, we want to use Jenkins. Jenkins as the engine of the deploy process. Okay? So someone use GitHub to change a Java, build a Java, and say, okay, do it. He don't know where it's deployed. That's not his problem. That's the Jenkins problem to do that. But Jenkins is just the engine. We need a brain to pilot Jenkins to see, okay, you can do the deploy. And for that, maybe it's digital AI, we don't know right now, but we want to split up the release management tools from the engine, because if you want to change the release management tool, that's not a big deal, because it just do the trigger to Jenkins to do the work they want to do. Why Jenkins and not maybe GitHub Actions? Because Jenkins is stable, he do a lot of stuff, and he works perfectly well. So at the end, maybe Jenkins for now, maybe in the future, GitHub Actions, maybe mix of them. We don't know right now, but Jenkins, it's the safer way for us. Thank you.